Hello everyone. Today we'll be just touching on the .NET framework, what it is, how it works, and supports your applications. The other thing we'll look at is namespaces and many top .NET framework class libraries, namespace which can be used within your application to extend its functionality. Lastly, we'll discuss how to use the help system to find more information about classes in the .NET framework class library. To begin, what is the .NET framework? We'll stay on a high level. You'll also find it very useful to read the books on the .NET framework to get a more thorough understanding of it. So, there are different parts of the .NET framework. The .NET framework is actually several things. So, there's the FCL, which is the Framework Class Library. Then, there's the .NET Runtime Host, and third, some utilities, etc. So the Framework Class Library is a series of classes that have methods that encapsulate common system or application-related functionality. You would need to use the classes within your FCL if you ever want to do anything that's interesting in your application. So the message box and the different controls from the toolbox which we've used are all contained within the Framework Class Library. You'd also need to use the .NET Framework Class Library if you want to access the database or open an XML file. You can imagine FCL as a series of classes which you didn't need to write, but are available to your application simply because you're writing a C# application. So now we'll look at the .NET Runtime Host. This .NET Runtime Host manages permissions for your application. They grant these permissions to run on your computer based on where the code came from. The code may have originated from the local desktop, from the internet, or from company intranets. This way, certain applications can be prevented from being executed automatically. For example, if you're surfing a website, those applications may not be given permission to access your hard drive, but could maybe display a form on the screen. There are different levels and permissions that are given, depending on where the code originated and whether it has been signed with a digital certificate. The .NET Runtime Host provides the common type system across all .NET languages. So a VB.NET application could be written that can reference code which is written in a C# application. This doesn't come automatically with any programming language. The .NET Runtime Host also ensures that no memory is left over once your application has finished using references to variables and objects. The memory will basically be cleaned up. There's also a number of utilities that come with the .NET framework. These include compilers, debugging tools, tools that automatically produce certain types of code or XML, and many other different utilities. You can see that if you sort the applications and files by type, there's a number of different .exe applications that are available. These are all types of utilities that are accessible through the .NET framework. We'll now look at how the .NET applications work. When you create an application and execute it, what actually happens behind the scenes? For example, how does the .NET framework runtime support the application? So when you compile your application, it creates an assembly. An assembly is usually filed with a .exe extension or a .dll extension. Within this file is a code, and that is called Intermediate Language, or IL for short. It's a temporary language that will be compiled a second time whenever your application is installed on its target computer. If you created a .exe application and gave it to someone running Windows 98, first time they run the application, it'll compile a special version of your application using the .exe assembly. It'll use the intermediate language inside the assembly that is specific to the actual processor and the module's memory. It kind of customizes the application to perform optimally on the particular system. The same would happen if you gave the application to someone else. It would go through that same compilation step, basically customizing the application and adapting it so it can be used on that operating system and processor. This is actually a unique feature of the .NET framework and is called just-in-time compilation. It allows your applications to run smoothly regardless of the operating system, although it has to be Windows based, and regardless of the speed of the processor. There's no need for you to do anything. The application will be tuned up automatically so it runs to its optimum ability on the other computer. The first time the person tries to execute the application, it'll go through the just-in-time compilation step, and thereafter it will use that optimized version of the assembly in order to run from that point on. The compilation step occurs only once. When the application is running, the .NET runtime will host the assembly. Hosting the assembly means it does many things like protecting the computer from memory leaks and malicious code that might have been written from where the application was originally launched from. It also looks at security violations. The runtime also provides access to the framework class library. This way, the application can access the file system or the database and anything the FCL will allow the application to do. Then there's something called garbage collector. And this is a special feature of the .NET Runtime host, and it will automatically remove anything from the memory that isn't needed anymore, such as object references and variables. All the functionality is provided without you having to call the runtime. If anyone tries to run your application on the computer, the .exe file will tell the computer that the .NET runtime is needed to enable it to run. If there's no runtime, an error message will appear on the screen saying it needs the use of the .NET runtime. It also provides a location where they can download the runtime, they can run the application. They should have the most recent version of the .NET runtime as long as they've been keeping their version of Windows updated with the latest patches. When you create an installation program which places your application on the hard drive and makes icons in your start menu, it can also include the installation for the runtime. If that particular version of runtime that you compiled your application with isn't on someone else's system, then it can install that as well during the installation routine. If they have the .NET runtime, then the program will just run. So the .NET framework is like a whole support system that won't allow your application to fail or break another computer. Let's now discuss namespace. So here I have a namespace called Lesson 7, and the namespace defines a code block in which your classes must live. So while methods, properties and fields have to live inside a class, classes have to live within the context of a namespace. The namespace lets you write code to avoid naming conflicts. So say you make applications for the finance department of an auto manufacturer. Another programmer works in the engineering department of the same company. Say that for the last few years you've been both developing .NET applications and created a car class. But both your car classes look completely different from each other. Now, if you're asked to work together to build a new application that merges both departments, you know you already have much of the code, but because you both have a car class, it may not be possible for .NET to know which car class to use. Each car class has different properties and methods defined. If you use the wrong car class, it may ruin the application. Now, you'll be fine as long as you use different namespaces. So you may use a namespace, so greatcars.finance.car, and your colleague's namespace could be greatcars.engineering.car. The name for this is fully qualified namespace, or fully qualified type name. The full name of the car class is used to differentiate the two classes from each other. The namespaces are like full names where you have the first name, middle name and surname, and it will distinguish you from anyone else who may have the same name as yourself. So let's look at an example of how to create our own namespace. We'll add a new class called car, and by default it gives you a namespace in C#. That is the named project. We can change this namespace to anything we want. So let's change it to greatcars.finance. That's my new namespace, and that can be used within my application. So now let's create an instance of our car class like we did in our last lesson. So car, my car equals new car. And run the application. So we get a message saying there are problems. The type or namespace car could not be found. Are you missing the directive or an assembly reference? So the reason it can't see our car class, even though it worked perfectly in lesson 6, is because the namespace we're running under is lesson 7, the default namespace for our form 1. If we want to use a class that's in a different namespace, we have to notify the C# compiler where it can find it. So here we get the IntelliSense appear, and we see greatcars.finance.car equals new greatcars.finance.car. Let's now try to run this application. And it works. So this is actually quite inconvenient because it requires a lot of typing. Now we can shorten this and use the shortcut called the using statement. At the top of your file, there are some existing default using statements. This lets you create a form so we can add our own using statement and paste greatcars.finance. When a car class is now referenced, we don't have to declare the fully qualified namespace because the using statement works as a shortcut. When we now run the application, it works. So let's return to our car class. And you'll see we can add more than one namespace and class to the same file. So greatcars.engineering, and here we will define a new class called car2. The only difference between these two is the namespace that they belong to. So the application will basically look to the using statement to know that it needs to use the car that comes from finance. We can confuse the compiler greatcars.engineering. So in our greatcars namespace, there are two sub-namespaces, engineering and finance. So let's see what happens when we run the application. We get a problem. It says, car is an ambiguous reference between greatcarsfinance.car and greatcarsengineering.car. So we've used two using statements, both namespaces contain car. C# doesn't understand which car we're referring to. So then we would need to use the fully qualified namespace. Now, whenever you find a class that you need to use for your application, this could be to access a database or open an XML file or a file on a hard drive. You'll need to use the fully qualified namespace or create a using statement that will include the namespace for the set of classes that you need to use. By default, you have many using statements already supplied. If you need to use something that helps you work through security issues with your application, then you might do something like system.security or media, or input-output, or diagnostics in order to determine how your application is running. Then there's various namespaces under the system namespace. This is the top-level namespace for the FCL. If we wanted to use isolated storage, for example, we could include that using statement and use all the classes that are supported by that namespace without having to reference system.io.isolated-storage every time we wanted to use that class. And that's also how we can use MessageBox without having to type system.windows.forms.messagebox.show. Because when you use Visual C# 2005 Express Edition, by default, That is a using statement which is included in the form that you create. So which classes can we use within our applications, and what namespaces can we look to? So there are a few popular namespaces that will allow you to do things. When you looked at system.windows.form, this gives you access to all the form and control related classes. System.data is the classes for all things related to data access, data set, and other database related objects. System.net allows us to communicate with the internet. System.web can be used to create ASP.NET web pages. System.io allows you to retrieve and read text from external sources, like files or the internet. There's also the string class and the text reader, which we'll use in our RSS reader application. The System.xml class lets us retrieve and read XML. It includes classes like the XML text reader, the XML document. System.text gives us ways to work with strings in a more effective way than by using the string class itself. It gives a class called String Builder, which optimizes our ability to work with strings. The best way to start learning about the various things that are available to you is by doing it yourself, by practicing, experimenting, reading, and looking at other code that other people have built, and by research, whether it be the internet or books. So now we should look at how to use the help system in order to find a few members of classes. It's quite simple, and you can use it in many ways to search for a given class namespace like system.windows.forms, etc. or roll through the contents of the help, or use the index to type in some keywords. This way it should come up with what you're searching for. There's also dynamic help available to you that is context sensitive. So basically, when you're typing, it will try to provide all articles in the help that relate to what you're typing. Another simple way is to use your cursor or the arrow keys and the shift key on your keyboard to highlight certain keywords, the namespace, and then hit F1 on your keyboard. This will bring up help for that particular item. The help is displayed in a tab just like the other items in the main area. So you can create a horizontal tab group to view both code and help simultaneously. We can move that back by selecting Move to Previous Tab Group. When we're looking up a namespace within the help system, we can start just go through using the links that are available. We can see examples and codes and the difference between Visual Basic source code and C# source code. We can copy and paste directly into our project and run it as a test project just to see how it works. Add a breakpoint, etc. So when you're developing an application, it's very helpful just to take time to browse through. So how can you bookmark, say, a section of help which you find particularly helpful? Basically, this is laid out similar to a web browser, and you have a URL for help on your computer. So you select and right click and select copy, and just paste that link in. So now whenever you want to look up the help that is related to that section of code, you just hold down the control key and click that link, and it will open up that tab in our main area. So that's quite an important tip to remember. So in this lesson we covered the .NET Framework, the Framework Class Library, the .NET runtime, and a little about utilities, the namespaces and why they're useful, and how to find out more information about the different classes and namespaces available within the FCL, and also the help system. So, I hope this lesson was helpful to you, and once again, I'll see you in the next lesson. Until then, take care and bye-bye.